All right, so friends, I'm on the worksheet 5.1, and I'm on the back side. So you said just 6 and 7?
Yeah, we do carbon classes.
Okay. All right. So here we go. So give the intervals where it's increasing and decreasing. Give the maximums and mins as ordered pairs. Okay. So problem number 6, we have, this is our equation. X squared minus 4x raised to the second. All right. So how do I want to approach this problem? I guess first thing I'm going to do is I'm just going to say x squared minus 4x, quantity squared. Quantity squared. Oh, come on. Come on. Squared is equal to 0. So let's get the zeros. Shh. So root both sides. Plus or minus of 0 is just 0. So then we can find out that x and x minus 4. So I find that x equals 0 and x equals 4. So right now, on my F chart, I have 0 and I have 4. And those are basically just roots. Okay? Let's take first derivative. So that's going to give me 2x squared minus 4x raised to the first, and then 2x minus 4. And then I'm going to set the derivative equal to 0. So that's just going to basically give me x squared minus 4x equals 0, and 2x minus 4 equals 0. Solve each of those. That's going to give me x equals 0, x equals 4, and x equals 2. Okay? So these down here, these values down here are where my slope of my derivative would be equal to 0. So horizontal. All right, so let's draw our F prime chart. So I have 0, 2, and 4. All right, so let's figure out where this equation itself is increasing or decreasing. So there's a couple ways. Another way we could look at this is we could say, hey, let's plug in the value of 10 to the original equation, which is going to give me 10 squared, that's 100, 100 minus 40, and then 60 squared. So this would give me a positive value. Let's pick a value like 1, which is in between the 4 and the 2. So I get 1 squared minus 4 gives me a negative answer. So that's negative 3. Negative 3 squared is 9. So it gives me a positive answer here. If I had chosen 1, or shoot, if I chose 1, I totally did that wrong. I'm sorry. And let's pick 3 and see what happens when I plug 3 in right here. If I plug 3 in, I get 9 minus 12, and that also gives me a positive. And then if I pick a negative number and plug it in, if I plug a negative number in, it's going to also give me a positive. So what this is basically saying is this graph, if we were to try and look at it just on Desmos, let's see if it shows us some clues of why it's positive, positive, positive. We have no sign changes. So that basically means we have all of these points of inflection that are taking place. So let's just jump on Desmos and see what our family says about this. Graphing calculator. So y equals quantity x squared minus 4x, quantity squared. All right. All right. So we found at 0, we found here, and we found here. Now, those are not points of inflection. Those are max, local maxes and mins. So the 0, 2, 4 we got. So the 0, 2, 4 we got. So let's see where I made a discrepancy on this. So that was plugging in. I plugged into the original. But let's take values here and plug them into the derivative. So if I pick 10 and plugged it in here, if I plug these values in here without having to do too much math, this is going to give me a positive number, that's giving me a positive number, so we're positive there. So from 4 to infinity is our graph increasing. 4 to infinity, it is indeed increasing. Let's see if I pick -3, if I plug it in, it shows us a negative scenario. So if I plug 3 into the derivative, that's going to give me 9 minus 12, which is -3. So yep, that does give me a negative. If I plug 1 in, what's 1 going to do? So that's negative times negative, which is positive. If I plug -1 in, I'm going to get positive here and negative here. So it looks like my sign line is negative, positive, negative. And that indicates that if it goes from a negative slope to a positive slope, this would have created a min. If it goes from positive to negative, this would have created a max. And if it goes from negative to positive, it creates a min. And so let's just make sure from -1 or so, from negative infinity to 0, was our graph indeed negative? Yes, it was. Was it in positive here? Yes. Was it negative here? Yes. Was it positive here? Yes. So it all works out with the sign line. So that's a definite way that you can go about doing some of these problems to jump on there. So intervals where it's increasing and decreasing. So let's say it's decreasing first from negative infinity to 0, and from 2 to 4. That's where it's decreasing. It's increasing from 0 to 2. And it's also increasing from 4 to infinity. Okay, and again, you can get all this information from Desmos. There's no reason why Desmos couldn't be helpful for you to label these things. And then give the max and mins as ordered pairs. Well, we could do that real easy on Desmos. We just type we have 0, 0, we have 216, and we have 4, 0. The 0, 0 and the 4, 0 are mins. The 216 is a max, or they're all locals. Ouch. All right. And number 7 says, graph the following and identify each below. Well, let's just jump onto it with Desmos because we can use it. X squared minus 3x minus 4. All right, so our typical parabola. Find the roots. Well, Desmos will find our roots nicely. -1, 0, 4, 0. Do the f prime chart. So our turning point on this problem is at 1.5. So it's decreasing from negative infinity. So if we wanted to make a sine line chart based on this. So f prime. So that gave us 1.5. So it's decreasing here, increasing there. So this refers to this as being a min. And then intervals where it's increasing. So it's increasing from 1.5 to infinity, decreasing from negative infinity to 1.5. Do we have a max min? We have a min. And we have it. Cool. All right, so Desmos works well for you. And I think I think you would have a pretty good opportunity to take a look at worksheet 5.2. And I think you can do 1 through 7. And this will actually be due on Monday because tomorrow is Friday, and Fridays mean we have real life. Tomorrow we're going to talk about warranties. And some of you are going to be shamed into having why you have a warranty on your cell phones when you have a cracked screen and you don't want to go drop it off for 2 weeks while they replace your screen. But I still have a warranty. Well, still have a cracked screen, but I have a warranty. Your screen's still cracked. So, silliness. So, sound like a deal? Everyone good? Everyone happy? No, not